السلام عليكم دكتور محمد،
عليكم
دكتور فهد.
السلام ورحمة الله وبركاته.
We can start now. ممكن نبدأ إن شاء الله دلوقتي. دكتور فهد فليتفضل.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. معكم فهد الغانم. تتشرف وزارة البيئة والمياه والزراعة ممثلة بإدارة الصحة والرقابة البيطرية بإدارة الدكتور علي محمد الدويرج. طبعا الدكتور علي يعتذر ويشكر جميع الحضور بسبب ظرف، وشركة بالتعاون مع ترو نيوتريشن هيفت وشركاء المملكة العربية السعودية شركة الإعمار العالمية والبيطرة بإقامة الندوة العلمية بعنوان زيادة ربحية مصانع الأعلاف من خلال مكافحة السالمونيلا وإدارة الرطوبة. كما تعلمون السالمونيلا من أهم الميكروبات التسمم الغذائي التي تنتقل من الحيوان إلى الإنسان عن طريق تناول منتجات حيوانية ملوثة ببكتيريا السالمونيلا، ويمكن الحد منها بتطبيق نظام الهسل في جميع منشآت الأغذية وفحص المنتجات الحيوانية في مختبرات معتمدة دوليا لضمان سلامة ومأمونية الغذاء للاستهلاك الآدمي، مما يعزز الهدف الاستراتيجي لوزارة البيئة والمياه والزراعة وهو تحقيق الأمن الغذائي. وتهدف من خلال هذه الفعالية التحكم والسيطرة على مرض السالمونيلا. فليتفضل منسوبو الشركة مشكورون.
السلام عليكم ورحمة الله وبركاته. شكرا دكتور فهد. أنا محمد الجمال، ريجونال مانجر تراول نيوتريشن اي فيد السعودية وعمان. بتشرف إني موجود معكم اليوم. بشكر إدارة الصحة والرقابة على استضافتنا للويبينار ده، وبشكر الدكتور فهد إنه قدمنا التقديم الكويس، وإن شاء الله يا رب نكون عند حسن الظن. Our presenter today will be Dr. Prince Nada. He is Global Program Manager for Feed Safety for Trail Nutrition High Feed. He will talk about process moisture management, salmonella control, and higher feed meal profitability. He will talk about 15 minutes, then we will translate Arabic. Then he will have the mic again for another 15 minutes, then translate Arabic, then Q&A. Please add your questions whenever you need on the chat box, and we will reply as much as we can. Dr. Prince, you can start now. You are welcome.
Thank you so much, Dr. Mohammed, for the introduction, and I'm really glad for this opportunity, and thank you for all the participants for attending this. Like mentioned, my name is Prince Nanda, and I'll be taking care of this topic for the next 15 minutes, and please feel free to ask questions. So the agenda for the first 15 minutes, like already mentioned now, the presentation is divided into two parts, and for the first 15 minutes, I'll be focusing on first part, and then later on we'll take the second part. So within the first part, what I'll do is I will touch on introduction to moisture management. That means I will explain a little bit that what moisture management is all about, how it is benefiting the feed millers around the world, how much money people can save with this, and that will act as a baseline for the understanding of moisture management. And later on, I'll dive a little bit in detail into surface tension, that is the importance of surface tension as far as moisture management is concerned. And then I will also talk about how we can make moisture management more effective by using sensor-based moisture regulation. So if you have a sensor on the lines in the feed milling, how that can help to make moisture management even more effective. So that'll be the part one, and then later in the part two, I'll talk a little bit on the importance of salmonella, how important it is, and how many difficulties it is causing around the globe. And I'll also share some experiences here from Europe, where I'm based. And then more importantly, I'll focus on formaldehyde, which I understand is widely used nowadays for controlling salmonella, and I'll highlight some of the negative aspects of formaldehyde and why we should not be using it, but also I'll be highlighting some of the alternates available in the market. So that's as far as the agenda goes, and let me go straight into the first point today, which we're going to discuss, is the moisture management. So we faced these three major challenges that you see on your slide in feed milling. And this is purely from a moisture management point of view, that there are a lot of processes involved in feed milling, as with any other factory production, let's say. There is this friction which produces heat, and when heat is there, we know moisture evaporates. So that's the number one challenge as far as moisture management is concerned. Number two and number three, especially important for a lot of tropical countries, but also Middle East, for example, there are a lot of environmental variations between summers and winters. The temperature fluctuate a lot, but not only summers and winters, but also mornings and evenings, there are a lot of temperature fluctuations. What this lead to is, it's difficult to maintain a consistent feed quality when the environmental variation is so high. And that's a challenge to deal with. And on top of that, there are also raw material variation. Think of variation in corn and soya. There are always variation in moisture and other parameters. So when we combine all these three together, what they lead to is moisture related problems, that we are not able to maintain optimum moisture within the feed to produce optimum quality. But then the next question obviously arises that, okay, if the moisture is a problem, but how big of this is a problem? Because we know we have 100 other problems today. There are viral diseases, there are antibiotic reduction, sustainability, energy savings, and there are multiple other things in the feed miller's mind. Why we should be concerned about moisture? And that's what I would like to tackle in this particular slide. I've taken an example of a very small feed mill which produces 15,000 metric tons per annum. So this is small by any standards in the world, but specifically for Saudi and Middle East, I know this is a very small feed mill. But let's take this as an example, a small example, just to understand the concept. Even within this small feed mill, what we can see is, if the moisture is not maintained in the right way, then there are implications on capacity utilization. That means the feed mill which is producing the feed in terms of tons per hour, they are not optimum. They cannot be utilized up to the full extent if the moisture is not right. Then, of course, there are implications on process loss. That means we start with certain moisture and we end up with certain moisture, and there are some losses in between during processing. And that has a certain value attached to it. Similarly, we know one of the important components within the feed mill is energy, specifically energy in steam and electrical energy for the pelletizer. And this energy, especially the energy of the pelletizer, is also the implications on this energy consumption if the moisture is not right. Then the PDI implicates the physical quality of the pellets, as we know. So the physical quality of the final pellets can also be impacted if the moisture is not managed in a right way. And last but not the least, the molds and microbiological profile of the feed is also important. If the moisture is not right, specifically if water activity is high or moisture is high, then that may have some unwanted consequence in microbial spoilage, and that also has an implication. So if we sum up all of these things, this is more than $100,000 even for this small feed mill. That means the implication of moistures are this big. Just to put it in perspective, I would like to showcase that this money is a lot of money even for this small feed mill. This means a nice Porsche car, for example. Even for this small feed miller. And if the feed mill is big, then we can see that how much moisture can lead to. So up to now, I've just gone through the explaining a little bit on the moisture management and drawing the baseline of our understanding. But then, of course, when we do moisture management, when we add moisture during feed mill processing, what happens? What is the mode of action within the feed mill? So that's what I would like to tackle in this particular slide, where we know if we add water, which is usually added during the mixer, Because moisture is a prerequisite for starch gelatinization, as we know, it's one of the component. If we want to achieve better starch gelatinization during conditioning, we should have this moisture added during the mixture. On top of that, if we are able to reduce the surface tension of this water, I'll come on to surface tension a little bit later. But for now, if we are able to reduce the surface tension of the water, it leads to better wetting, better mixing of this water. Thereby, like I mentioned, better cooking, or in scientific terms, better starch gelatinization in the conditioner. And when this particular mash then move on to the pelletizer, which is better gelatinized, moisture is better penetrated, it'll be able to pass out very easily through the die. And what does that mean is lower friction, and lower friction means lesser energy consumption at the die. But also it means higher throughput. When mash is able to pass out through the die a little bit easily, that will lead to higher throughput. And overall, if better starch gelatinization, because starch, when it is gelatinized, it is a little bit sticky. It brings feed particles together. This leads to better feed quality also. So this, in a very short, highly overview how the mode of action of process moisture management is. So that's what I've tried to explain in this slide. So up to now, then we have discussed what the moisture management is all about, how it impacts a feed miller, and what is its mode of action. Then we can make it more effective. This moisture management, we can make it more effective by using two techniques. So number one, which I'm discussing just now, is surface tension. But before going into deep of surface tension, it's important to understand what is surface tension in the first place. So surface tension, as you see, is all around us. It's all around us, and the insect, how they swim over the water is because of surface tension, and the bubbles which are formed, these bubbles are because of surface tension. If somebody of you is interested in space movies where people go to zero gravity, then the water droplets are always spherical, and they're always spherical because of surface tension. So it's an important phenomenon around us, which is always present. So purely in physical terms, surface tension is the tension on the surface of the water, which brings the molecules towards the center, as you can see in this image. So there is some tension which keeps it round, the droplets round. So that is basically surface tension. And how can we reduce it? So surface tension has good and bad elements around us in many ways, but as far as feed milling is concerned, we would like to reduce surface tension as much as we can, because the more the surface tension in water, the water is not able to penetrate inside the feed particles as it should. So it's beneficial for us if we reduce this surface tension in order to facilitate the penetration inside the feed particles. And then how can we reduce the surface tension? One of the ways to do that is using the right kind of surfactants and right kind of chemical products, for example. And they reduce the surface tension by this mode of action. So I'll not go into the details, but these surfactants are a very wonderful molecules which has both hydrophilic and hydrophobic ends, and thereby they are able to reduce the surface tension as indicated in this slide. So when surfactants reduce the surface tension, this surface tension is nice for a feed miller because now the water is able to penetrate nicely. We did a study here at Round Nutrition, I think a year back. We compared different products from the market, more than 15 products, not only the blends, but also the emulsifiers. And we were very positively surprised that Phylax 4-HC liquid, which is one of our products, we were able to find the surface tension was the lowest in the market. And this is because the blend which we are using, the ingredients which we are using, they are able to reduce the surface tension to a very large extent. And lower the surface tension, like I mentioned earlier, better the penetration, and all the benefits of moisture are better. But not only it's the lower surface tension which helps in better penetration, but we found out in one of the trials with our partners that it also leads to higher antimicrobial effect. So whenever the surfactant was present in one of our antimicrobial products, we were able to have a better effects against Enterobacteriaceae in this case. So that means better hygiene also. Overall, in a nutshell, if I have to combine it, surface tension implications are uniform moisture addition and absorption. It will lead to lesser lumps. And now more moisture can be added if surface tension is reduced. So overall, if somebody wants to add more moisture, then the moisture can be added, and higher retention of this moisture also, because moisture penetrates a little bit deeply inside the feed particles, and hence its ability to retain is higher. So with this, I would like to go to the next session. I'm a little bit running behind on time, but I think this is important to discuss on sensor-based moisture regulation also. So the part one was really the surface tension, and the second one is sensor-based moisture regulation. So the usual way of moisture addition usually is that we have some sort of product. It can be an emulsifier, surfactant, preservative blend. We mix it with water usually, and then spray it inside the mixer. This is the usual way a lot of feed mills around the world are doing. But there is a problem with this way of moisture addition. The problem is, this is a live case, as you see on your screen, for one of the feed millers. There are huge moisture variations. So sometimes the moisture in the mixer is more than 12%, 13%, even 13.5% in some cases. While in other cases, there is a lot of, excuse me, there is a lot of dry feed that the moisture is very less. So this is a 6-month data from a feed miller, a live case. That's why the fixed moisture addition does not work, because if the raw material moisture is high and we continue to add the fixed moisture, then the overall chances of molds are high. While when the batch moisture is lower and we continue to add the same amount of moisture, then there is a lot of nutrient wastage. We supply dry feed into the market, which leads to economic loss. So that's why it's very important to use a smart way of moisture addition. And I'll try to showcase a small video. Hopefully I'll be able to play it. Let me try. Yeah, I hope you can see it now. This is a smart sensor-based moisture regulation video where you see there is a small sensor downstream of the mixer, and this sensor measures the moisture on a real-time basis, or nearly real-time basis, and then it sends this signal to the dosing equipment, to the centralized unit, that the moisture is a little bit less than it should be. The set point is 13%. We want the moisture to be 13%, and then this dosing equipment knows the moisture is less in that batch, and then it sprays the moisture and try to bring it closer to the 13%. And now you see in the next batch, it is coming closer to the 13%, or exactly 13% for that one. Yeah. So this is the way the sensor-based moisture addition can work, and we are trying to do this by using our moisture management system, which has a sensor in it. Overall, just to sum it up, the smart sensor-based moisture regulation can have a number of benefits. It will overall lead to higher average moisture, as you see, rather than just fixed moisture addition. Overall, it will lead to lower standard deviation. That means lesser deviation. That means more uniformity in the feed, and thereby more uniform feed is better for the animals. And when the system is smart, that means it knows when to add the moisture and when not to add the water. That means the chances of susceptibility for mold growth is also less. And that's what you see here. And overall, the system leads to much better milling efficiency, because we are adding the water when it is needed, not adding when it is not needed, thereby higher milling efficiency in terms of throughput and specific energy, etc. also. So that is the overall value proposition. And with this, I would like to stop with the first session, and then later on continue after the Arabic translation, which Mohammed will be helping me now. Over to you, Mohammed.
Thank you, Prince. I would share the screen again from my side to start from the first one.
Yeah, please.
Yes, to start from the first. Can you see my screen now? السلام عليكم. اتمنى ان تكون السكرين عندي واضحه عبد الله. السلام عليكم. هي الهدف اليوم ان احنا نتكلم على زياده ربحيه مصانع الاعلاف من خلال مكافحه السالمونيلا واداره الرطوبه. والاجنده هتنقسم لحاجتين زي ما احنا اتفقنا عليها، ان هي الانترودكشن على المويستر مانجمنت اللي احنا من خلالها بنوصل للكنترول بتاع السالمونيلا، لان المنتج عشان نقدر نوزع التوزيع الجيد للمنتج اللي بيحافظ على السالمونيلا لازم نعمل له سبرينج كويس، فكون لازم نعمل حاجه اسمها مويستر مانجمنت ونستفيد من الووتر اللي بتتحط علشان نقدر نحافظ على نقدر نوصل اكبر كميه من الميه اللي فيها الانتي سالمونيلا للطيور، بحيث ان احنا نواجه هذه المشكله. فبنتكلم في هذا الجزء الاول على المويستر مانجمنت، ازاي هنحافظ على كميه الميه الموجوده جوه العلف، لان هي اساسيه ونيوترنت فاليو مهمه جدا للطيور، وفي نفس الوقت مهمه لمصنع العلف لانه بيخسر فلوس لما الووتر دي تطلع من الجرينز او المدخلات بتاعت العلف. ثاني حاجه السنسور بيزد مويستر مانجمنت او التكنولوجيا المستعمله او الديجيتاليزيشن اللي احنا بنستعملها علشان نحافظ على الابلكيشن ونوصل لافضل وضع ممكن للرطوبه اللي هيوصلنا بعد كده لافضل وضع ممكن للسالمونيلا كنترول. ثاني نقطه السالمونيلا كنترول، ايه هي مشاكل السالمونيلا وايه الامبورتنس بتاعتها وازاي نعملها كنترول. وعلشان احنا شركه السلوجان بتاعنا فيدنج ذا فيوتشر، فبيهمنا الكونسيومر بتاع الهيلث بتاع الكونسيومر نفسه والهيلث بتاع البشر والفراخ نفسها. فعشان كده احنا هنتكلم على الفورمال هايد بيزد فيد اديتيفز لان الفورمال هايد اصبح باند. هو اتكلم على ان بسم الله. اول حاجه ان الرطوبه عشان نتحكم فيها لازم نتحكم في الفراكشنز اللي موجوده جوه، فبنقلل الكثف بتاع العلف اللي موجود. تاني حاجه الانفيرومنتال فاريشن، الجو هنا في الميدل ايست حر جدا جدا جدا، فبنفقد كميه ميه من الرو ماتيريالز اللي موجوده عاليه جدا، هي تعتبر ماده مغذيه للطيور والحيوانات، فاحنا بنرجع الماده المغذيه دي لمكانها تاني ونحافظ عليها جوه حبوب العلف. تاني حاجه الرو ماتيريال فاريشن، الرو ماتيريال الفاريشن نفسها في اختلافات في الرو ماتيريال ما بينها وبين بعضها في الرطوبه، ممكن باتش يبقى رطوبته اعلى وباتش رطوبته اقل، فاحنا عايزين نطلع كل الباتشات بنفس كميه الرطوبه الموجوده فيه. هو ضرب مثل بمصنع صغير بينتج حوالي 15000 طن، عشان يعرف مدى التوفير اللي هيعمله المنتجات دي وازاي لما يحط منتج بيحافظ على السالمونيلا وفيه رطوبه في نفس الوقت هيبدا يحافظ على المنتجات. ضرب مثل ان هو هيوفر في الكباستي بتاعته لما هتزيد 5% فقط هتوفر $25000. لو هو الرطوبه حافظ على 1% ان هي تفقد، مش هيضيفها، حافظ على 1% ان تفقد، هيوفر $66000. لو وفر من الانرجي الكهرباء المستعمله 10% هيوفر $1567. الحبايه العلف هيخليها انتكت وسليمه وما فيش فريجمنت فيها 5% هيوفر $12900 تقريبا $13000. لو عمل مولد لو حافظ على ان هو البريزرفيشن بتاع العلف في الفارم ان هي ما يحصلش فيها اي مشاكل تعفنات او حاجه او شيء من هذا القبيل هيوفر $20000. فده التوتال $126000 تقريبا يقدر يشتري بيهم عربيه بورش. فهو بيدي هديه عربيه بورش السنه لكل مصنع علف صغير من التوفير اللي هيطلعه، بالاضافه الى رفع كفاءه حبايه العلف بتاعته او الحفاظ على كفاءتها. هيبدا يعملها ازاي؟ هو احنا كلنا بيبقى في عندنا الرطوبه بتضاف على مرحله المكسر، لان المكسر ده اللي بيحصل فيه جيتاليزيشن او مرحله التجهيز للطبخ بعد كده، فيهمه ان هو يخلط الميه كويس جدا بالعلف اللي هي اصلا اوريدي جزء من مكونات العلف. فاحنا بنحط المكسر بيضاف فيه الميه وبيضاف على هذه الميه المنتج الذي يقلل من التوتر سطح الماء، فبيسهل دخول الماء داخل المكونات العلف ولا يسمح على خارجها، لان احنا عارفين واللي هيجي بعد كده ان حاجه اسمها التوتر سطح الماء، التوتر سطح الماء عالي فممكن حشره تقف عليه، بس انا هجيلها في السلايد بعدها. ثاني حاجه الكونديشنر ده بيعمل كوكينج زي ست البيض بالظبط. الكوكينج كويس عشان يبقى كويس لازم ندخل الميه كويس جوه حبايه العلف عشان تستوي كويس وتطبخ كويس. فده الاهميه بتاعه السيرفيس تنشن، ان انا لما اقلله الميه تدخل جوه كويس جدا جوه حبايه العلف فهتطبخ كويس جدا، فانا هطلع حبايه علف مطبوخه كويس، الطائر هيستفيد منها كويس، فبالتالي هتعمل البليتلايزيشن كويس فهتقلل الفراكشنز والكسر اللي موجوده فيها. والفراكشنز والكسر اللي موجوده فيها دي بتبقى الحاجات الفاينز ومعظمها البريمكس، فيهمنا ان احنا ندخل البريمكس كويس جدا جوه الحبايه، فكده احنا حافظنا على الحبايه بالقيمه الغذائيه بتاعتها سواء ميه او بريمكس. ثالث حاجه ان احنا بنقلل الطاقه المستعمله في الانتاج، فدي فايده لصاحب مصنع العلف وفايده للمربي لان كل حبايه علف مظبوطه بتكلفه قليله. السيرفيس تنشن زي ما احنا قلنا السيرفيس تنشن ده حبايه الميه ممكن الطائر يقف عليها، فعلشان تدخل جوه حبايه العلف لازم اقلل السيرفيس تنشن بتاعها علشان تتحول من ان اكتف ووتر لاكتف ووتر، فتدخل جوه حبايه الميه وتصبح مكون اساسي من حبايه الميه جوه حبايه العلف، فيستفيد منها الطائر ويحولها، لان احنا لو عملنا تحليلات للعلف الرو ماتيريال هنلاقي الميه جزء اساسي منه، فمعنى كده ان الماء الجزء الاساسي ده بيساعد في التحويل للطيور، عشان كده احنا بنحاول نخلي الميه تدخل مكانها الطبيعي تاني. دي ازاي السيرفيس تنشن بيشتغل وازاي يقلل السيرفيس تنشن. بيقلل السيرفيس تنشن، دي تجربه اتعملت على السيرفيس تنشن بالمنتجات بمعظم المنتجات، وجدوا ان احنا بفضل الله بنقدر نقلل السيرفيس تنشن، فبنخلي اعلى نتيجه تطلع من الكميه في الرطوبه اللي موجوده جوه الحبايه، فده اللي بيأثر على الاف سي ار بتاع الطائر، بيعمل له ديكريزنج فبيخلي تحويل الطائر اعلى. دي تجربه بمعظم المنتجات، كمان لقى فيها تاثير على السالمونيلا وتاثير قوي على السالمونيلا، وده كان اللي درو الاتنشن ان احنا ممكن نستفيد من الرطوبه في الكنترول بتاع السالمونيلا، لان احنا نفيد مصانع الاعلاف ونفيد المربي بزياده عدد كميه الرطوبه وتوزيع الرطوبه على حبايات العلف كلها، وبالتالي يوزع معاها الكنترول على السالمونيلا، فما فيش حبايه علف بتطلع الا فيها منتج للكنترول على السالمونيلا وفي نفس الوقت محافظ على الرطوبه. ايضا بنستفيد ان احنا اليونيفورميتي بتاع حبات العلف، كل حبات العلف متجانسه، كل حبات العلف فيها نفس القيمه الغذائيه، كل حبات العلف فيها نفس كميه الرطوبه، فبتديني اف سي ار افضل. بعد كده السنسور بيزد ده اللي هو الديجيتاليزيشن في الفيد ادز مطلوب جدا، لان انا بعمل دوزنج لرو ماتيريال ومعاها ميه او كورن وصويا مش شايف قد ايه، انا بضيف كميات وبتتعمل لها ميكسنج بلايندلي، فلذلك ان انا لما اجي اضيف حاجه عليها عايز اضيفها بتكنيك عالي بحيث ان انا اوصل لاعلى كفاءه ممكنه من المواد اللي انا ضايفها ديت، فده مهمه السنسور بيزد مويشر. هو بيحول الشكل الموجود قدامنا ده، لان في فاريشن في المويشر في كل الحبوب اللي طالعه، فاحنا مش عايزين الفاريشن اللي موجود، احنا عايزينهم تقريبا اولموست اون ذا سيم ليفل عشان كل الطيور تبقى اون ذا سيم ليفل اوف مويشر، اوف ذا سيم ليفل من النيوترنت وسيم ليفل من المكونات الغذائيه، فكل الطيور تستفيد، كل الطيور تبقى متجانسه، كل الطيور تبقى على نفس الليفل من الاستفاده. وكمان بيقلل الريسك بتاع المولد جروس، وبيقلل الانرجي وبيقلل الويست اللي موجوده جوه، فبنستفيد بحاجات كتير جدا وبنوفر حاجات كتير جدا من استعماله، بالاضافه للسالمونيلا كنترول. ده الفيديو اللي هو عرضه، الفيديو ده بيقول ان احنا بنوفر تقريبا في الرطوبه او بندخل الرطوبه اللي بتفقد بنوفر منها حوالي 1%، والستاندرد فاريشن هنا بيبقى النص، في اليونيفورميتي فيبقى في يونيفورميتي ما بين الفيد بارتكلز اللي موجوده كلها بتبقى واحد. الباتشز الباتش تبقى واحد. وفي هنا احب نقطه اعمل هايلايت عليها قوي، ان احنا بنحافظ على الرطوبه اللي موجوده جوه حبايه العلف، واللي هي جايه بطبيعتها ومش عايزينها تفقد، لان هي لما بتفقد في مرحله الصناعه بتقلل من كفاءه علف، وفي نفس الوقت بتخلي صاحب المصنع العلف يخسر. احنا مش بنضيف ميه، احنا بنحافظ على كميه الميه اللي جايه جوه حبايه العلف ان هي تفقد، لان طبعا احنا عارفين ان المصنع بيحصل له الاول الهامرنج ده بيعمل منسنج لحبوب العلف فبتبقى بودر، في الفتره دي بتفقد جزء من الميه اللي موجوده فيها، والميه اللي موجوده فيها دي مهمه جدا للطيور. فكده كده اثناء الطبخ اللي هو زي ست البيت ما بتعمل، بتطبخ بتحط ميه، بتحط كميه الميه الطبيعيه بتاعت العلف تاني علشان ترجعه لطبيعته، فيبقى الطبخ بتاعه مظبوط، فيقلل الفراجمنت، وفي نفس الوقت يوفر للمربي الماده الغذائيه اللي جايه في حبايه العلف اللي هي الطبيعيه اللي ربنا خلقها. I will let now Prince to continue for the second part of Salmonella control, then I will translate again.
Yeah, okay, sure. Thank you so much. And I'll be sharing again. Can you see it now, my screen again? Can somebody confirm, please? Can you see my slide or not?
Can you share it again, Prince?
Okay, let me try again.
Yes, we can see it. Food safety.
Yeah, perfect. Thank you. Okay, so thank you very much, Mohammed, for giving a summary in Arabic as well. And then now, yeah, I see a lot of questions coming in chat. Please keep them coming, and they're very interesting, some of them, and we'll take them after this short round also. So in the next session, now in the next 15-20 minutes, what I'll be talking on is salmonella control. So it's a very broad topic, as all of you know. It'll not be justice to do it only in 15-20 minutes, but I'll try my best to indicate the importance of salmonella. So that's what majorly I'll be focusing on, that how salmonella is important, in what ways it is important. I'll also share some data from European Union also. So, and then I'll move on to formaldehyde-based feed additives. So that's the idea in the next 15-20 minutes. So let's get into it. So as you might be knowing that within European Union, every member state has to notify whenever they find a salmonella in feed or food. They have a system in place to do so, and that's why we have some nice data coming out of this rapid alert system. So they call it as RASAF, Rapid Alert System for Food and Feed. And I'm showcasing you the data for 2018. So not that old data. What we found out of all the notifications, what all the member states, all the feed millers, all the food producers have sent to this particular agency, is that for all the kinds of hazards, so they not only have to notify salmonella, but also they have to notify any kind of food hazard or feed hazard. Think of mycotoxins, pesticide residues, allergens, and all other things also, as you can see here. Out of these, as you can see, maximum notifications were of pathogenic microorganisms. That means these pathogenic organisms, which salmonella is a part of, was notified to the highest extent in 2018. Now we dig a little bit deeper that where this pathogenic microorganism was coming from, or all these kinds of hazards were coming from. The main source was fish and fish products, but also feed, poultry and poultry products. That means all animal related things. So this indicates that, number one, in short, pathogenic microorganism is a big problem as compared to all other things. But also where this problem is coming from in human chain is also via feed, via poultry products, via fish products. And now this was about pathogenic microorganisms. If we zoom a little bit only on salmonella, and now in this particular quite busy graph, but what you see is there are a lot of microorganisms listed: salmonella, listeria, E. coli, campylobacter, etc. Out of these, you see the highest share, a lion's share, as they say it, is of salmonella species. That means out of all the microorganisms, salmonella is the highest reported pathogen, which is, again, you can see here, is coming from poultry meat and poultry meat products, meat and meat products, etc. So this makes it very, very important for our industry to control. But I think the story will be only half said if we don't talk about humans and only talk about animals, because it's the chain, and everything then reaches the humans, and it's important to take human safety into account also. So I pulled some data which you see on this slide. As far as non-typhoidal salmonella is concerned, salmonella can be typhoidal and non-typhoidal. So non-typhoidal comes from animals. So it only comes from animals to humans. Globally, there are 155,000 deaths because of this kind of salmonella. It's a major killer around the world. And similarly, so not only it leads to mortality and morbidity in humans, but also it leads to lots of economic loss in human population also, as you can see here. So this is just to showcase you that how important salmonella is and its implications on animals, but also humans. It's a notorious organism. We know salmonella is everywhere, nearly everywhere. So that's why it's very important to protect the entire chain, starting from raw materials, feed mill, logistics, water, production animals, biosecurity from pests and hygiene. It can enter the chain from anywhere of these areas. And as they say, the chain is only as strong as the weakest link. So there should not be any weakest link in this in order to prevent salmonella. So multiple strategies has to be put in place. And unfortunately, there is no golden bullet as far as salmonella is concerned. But sometimes, and this brings me to the last section for today, which is formaldehyde-based feed additives. But sometimes formaldehyde is being used as a golden bullet for controlling salmonella, but also other microorganisms. And I would like to argue in this particular section that why it's not a good idea to use formaldehyde as a golden bullet to control salmonella, but also other things. And I would like to highlight and argue on the many negative effects of formaldehyde and formaldehyde-based feed additives, which can bring to animals and humans. So first of all, we know this part. I think most of us know that formaldehyde's effect on humans. Environmental Protection Agency has classified formaldehyde as a probable human carcinogen. So that it can probably cause carcinogen. There are multiple studies on that. Some people don't agree with that. We can debate over at what dose rate it causes, but probably it leads to carcinogen. It has carcinogenesis properties. Also, more specifically, it leads to myeloid leukemia, one type of cancer in humans at certain dosages. It has also been found out. But this story, I think, more or less, this particular angle of formaldehyde we have been hearing in news, different social media platforms for quite some time now. But more importantly, in this particular talk, I would like to argue on the case that formaldehyde is not only bad for humans, which we know, but also for animals. It has negative consequences for animal performances also, and I'll pull some studies related to it. So let's start with effect on lysine. Lysine, as we all know, is an important component, a nutritional component, important amino acid of any poultry diet or any other animal diet also. Now, formaldehyde is known to react with this amino acid and thereby binding it, thereby it may make it less available and could also possibly alter growth performance, as you see in this particular study. So total lysine in the formaldehyde-based diets was considerably lesser. In all these cases, you see this is formaldehyde, it is lesser than no formaldehyde. And similarly in low crystalline amino acids also. So that means it leads to binding, it leads to may lead to lesser bioavailability of lysine. So that's number one. If we see the complete effects then in animals, leave diet as such. So this is a particular data from broilers where they have inculcated different levels of formaldehyde. As you see, this is the increasing levels of formaldehyde. This is lowest, middle, high, and absence of formaldehyde. And if we specifically look at average daily gain segment, you see the average daily gain is going down and drastically low when the formaldehyde is very high. So this is an indication. Also, some of the data is statistically significant even when formaldehyde is used. It leads to effect in broilers. If we talk about feed to gain ratio, also there are negative consequences for broilers. So this is something to take care of. then also in layers, there is a negative consequence, as we know. As in this particular study, they have found out the laying rate was reduced and drastically reduced at a very high dosage, but also somewhere in the middle, there was a numerical reduction, if not statistical reduction, in using in layers. And then we also know for ruminants, there is this particular study on ruminants where they have found out that the final live weight, so this was done on lambs, and they used the various raw materials. So you see on top, these are raw materials, some cotton meal, soybean meal, I guess, and when they use non-treated and treated, so non-treated and treated is formaldehyde treated, and non-treated is of course not treated and treated is treated with formaldehyde. They found out reduction in final live weight even in lambs. So this is a negative consequence. Also, in one of the studies in one of the other species, they have found out that the formaldehyde alters the gut microflora also. It leads to increase in Clostridium and Clostridial species within the gut. That is a negative consequence. So now I've talked about that it binds with lysine, it leads to negative consequences in gut. It has negative consequences on broilers, layers, and ruminants altogether, and this data is there. And very credible research also. So if we know that negative now formaldehyde is bad for humans, as we know, but also for animals, what to do about it, what we can use as an alternate. Unfortunately, there is no one-to-one alternate available. We have to divide and conquer the alternate for formaldehyde. And then as we like to see it, for pelleted feeds, if the objective of using formaldehyde is shelf life extension, then we have a product called Filex-4 HC liquid, which has shown excellent results. I'll be showing you in the next slide that how it has been proven to have better shelf life compared to formaldehyde, and how it can act as an alternate. But also, if the pelleted feed, the main objective is of feed hygiene, then there is a product called Faisal Flow, and how it can have the overall impact. We can also use it along with moisture management and thereby countering formaldehyde. But I think the biggest challenge is with the mash feeds, which are not heat rated. And I'm not sure how big they are in Saudi Arabia at the moment. But if those kinds of feed are the major issue, then we really need a very strong product, somewhat unbuffered organic acid, high amount of preservative, feed hygienizing nature of it. And that's what we have seen with Faisal feed. So I'll showcase you now some of the evidence of each of these products that what we have seen in our research. So first one is Filex-4 HC liquid, which has shown some effect, actually quite nice results as far as shelf life extension is concerned. We found out, very surprisingly, 3 times better shelf life using Filex-4 HC liquid as compared to formaldehyde. Very happy that we were even positively surprised. We duplicated this test, retested it just to confirm the findings, and we were able to find it that the Filex is much better than formaldehyde as far as shelf life extension is concerned, as you can also see the pictures from this test now. So that's number one. But also we benchmarked Filex-4 HC liquid, which is the product which I'm talking about, also in comparison to many competitors in the market, and we found out the shelf life is better than many other competitors in the market. So this is one of the studies which we have done in the past. But then, so this was shelf life part of it. But if we really look into now salmonella control, and especially now mash feed, you can see this is coming out the values are of salmonella count in CFU per gram. And we have been using Faisal feed in this case, one of our top product as far as mash feeds controlling salmonella is concerned. We were really able to reduce it to a very, very low extent using 2 different dosages. So that means replacing formaldehyde is possible if we make the right strategy, right plan, and set our objectives right, and then using the right product. And this is one of the other data which I want to showcase here. that how organic acids act, of course, their dosages, their with time and their dosages have a different effect. And yeah, this is just to showcase we do these kind of studies, and if somebody is interested in knowing more, I can of course go a little bit in detail, but I'll skip it for the moment. Yeah, then one of the reasons we should be using organic acids over heat treatment and other aspects is decontamination prevention. Yeah, excuse me that this is a little bit crowded slide, but what does this indicate? This arrow on all these graphs, but particularly indicates is recontamination. So we sort of simulated the conditions in the field where we can have a contamination during transportation, during storage, or even at the level of feeders, etc. So we simulated that conditions in the laboratory environment, and we found out all the treatments with Faisal were even after recontamination were lower. They increased a little bit and then have gone down, especially the treatments as compared to control in different kinds of raw materials. So that's something we have also done with one of our partners, broiler performance study. That means sometimes people think using Faisal or using moisture management for salmonella control. So now I'm talking about pelleted feed. So some people do use in pelleted feed moisture management and some sort of preservative, and then think that probably the broiler performance will not be nice. But what we found out in this particular study was we were not only able to control salmonella and enterobacteria and feed hygiene, etc., but also slightly improve the animal performance also, as you can see. So there were 2% addition of moisture in these cases along with Faisal flow, but also we added the product, of course, and then we see a slight reduction in FCR in both of these cases, even after adding a lot of water. So that is something to note. So with this, I bring to the end of both the sessions, and I would just like to summarize it in brief now before we move on to the Arabic translation and later on the questions. We discussed in the first session that how moisture management, what is moisture management and how it can impact feed millers and its mode of action. Hope you remember the red Porsche, that it's a lot of money using moisture. But then we focused on how to make moisture management more effective. We talked about surface tension reduction, that how it is very important to reduce the surface tension to make it more effective. And I've showcased you many products who reduces surface tension. Then I talked about sensor-based moisture regulation, how using the moisture just the way we do it now with the fixed moisture addition is not enough, and we should have a sensor-based moisture regulation, and there are a number of benefits in doing so. And then we moved on to the second section. We talked a little bit of salmonella, how important it is. We talked a little bit of data from Europe, that how important of a microbe this is, and how difficult it is to control, and how a lot of us are using formaldehyde-based feed additives or formaldehyde to control it, and why it is not the best option to do it, and what we can, and then we talked about negative consequences of formaldehyde and different species, its binding with lysine, but also negative effects on microflora of gut. And then finally, we also talked about some of the alternates in Phylex and Faisal as far as formaldehyde based feed additives are concerned. So this is it for me for the day. And yeah, thank you very much for this opportunity. And I see a lot of good questions, and I'll come on to that after Mohammed has translated it. So over to you, Mohammed.
Thank you, Prince. I will share my screen to start to translate the second part. Can you see my screen starting from salmonella control, which okay. استكمالا للجزء السابق، احنا وقفنا عند ان الجرش بيؤدي الى خساره من 2 ل 3% لمصانع الاعلاف، واحنا عشان نرجع الخساره دي بنضيف المضاد السالمونيلا، بنضيفه على طريق الماء. فقلنا نستفيد من الموضوع ده ونرجع الخساره اللي حصلت من الجرش ونضيف معاه مضاد السالمونيلا عشان نضمن توسيعه على توتال العلف كله، يبقى كل مضاد السالمونيلا موزع في العلف كله ونعرف نعمل سالمونيلا كنترول. second. بعض الابحاث لقت ان وجود 979 حاله باثوجينيك مايكرو اورجانيزم لما حللوهم طلع منهم 330 حاله جايين من السمك، 313 حاله جايين من الفيد، و265 حاله جايين من البولتري. فكل ده ريبورتد للانيمال فيد. فكان لازم ناخد لوكينج على الفيد وازاي نعرف نعمل نشوف السالمونيلا بتيجي منين علشان نقدر نعمل كنترول عليها. فكان جزء من السالمونيلا من الاجزاء كان جزء من الاجزاء اللي بتجيب سالمونيلا هو الفيد. بعد كده السالمونيلا في اوروبا وجدوا ان هي مشكله كبيره جدا وبدات تعمل مشاكل في الهيومن سيكتور، فهم مهتمين جدا بالهيومن سيكتور والانيمال سيكتور. عندهم انيمال ويلفير وبعدين صحه الانسان تهمهم جدا جدا. فكان موضوع السالمونيلا مهم، لازم يعملوا له ريزنج ولازم يحلوه. لقوا ان السالمونيلا بتاثر على الانسان في مشاكل كتير جدا. عندهم ديسس حوالي 155,000 من بوبوليشن، حوالي 7 مليون ماتوا بسبب السالمونيلا، وده ادى لهم الى خساره اقتصاديه حوالي 132 مليون يورو، ودي كانت حاجه كبيره جدا. فبداوا يهتموا اكتر بالموضوع ويبحثوا فيه علشان يغطوا موضوع السالمونيلا اللي هو مهم جدا، مش ليهم هم بس، بل لينا احنا كمان في الميدل ايست كعرب، لان صحه الانسان تهمنا جدا، وصحه الانسان تبدا دايما من صحه الحيوان. علشان نوصل لهيلسي الانسان يبقى هيلسي لازم ناكله اكل هيلسي. فكنا لازم نعمل كنترول للسالمونيلا في كل المراحل. السالمونيلا كنترول في الفيد ميلز، انا عايز اضيف نقطه هنا. السالمونيلا كنترول ليست فقط في الفيد ميلز، السالمونيلا كنترول ده بروجرام، لان لازم نعمل كنترول على السالمونيلا في كل الاجزاء، في الرو ماتيريال، في الفيد ميل، في اللوجيستيك، في الانفايرمنت، في الووتر، في البرودكشن، في البيتش كنترول. لذلك السالمونيلا كنترول مش هتبدا فقط من مصنع العلف، السالمونيلا كنترول هتبدا في كل مراحل انتاج الدجاج. ولازم يبقى لها سالمونيلا كنترول بروجرام عشان نعتمد على العلف لوحده فقط نقضي على السالمونيلا. دي حاجه صعبه. اسهل حاجه ان احنا نقضي على السالمونيلا فيها هو العلف، لان العلف مكان سهل السيطره عليه. ومدير مصنع العلف سهل ان هو يعرف المشكله جايه منين عنده ويعمل لها ديتكشن ويعالجها بسهوله. مش بالسهوله اللي احنا متخيلينها، لان هي محتاجه تكنولوجيا في المعامله، ولكنها جزء من الحلقه اللي احنا بنغطيه. وان شاء الله دي تبقى اول السلسله اللي احنا نبداها مع الوزاره، ان احنا نبدا بمصنع العلف، بعد كده نبدا نتطرق للسايكل كلها والسالمونيلا كنترول بروجرام كله، اللي بدايته يعتبر مصنع العلف والرو ماتيريال. واحنا حابين نعمل هايلايت على ان الهيومن هيلث حاجه مهمه جدا لينا. فبنقول ان احنا عندنا ناس بتعمل كنترول على السالمونيلا بالفورمال دايت بيزد فيد اديتيف عشان والمويشر مع بعض. وجدوا ان الفورمال دايت على الاحصائيات بتاعه الاي بي اي اللي هي الانفيرمنتال بروتكشن ايجنسي بيسبب كانسر للانسان. فدي حاجه عشان كده هو بروهيبت في اوروبا دلوقتي وما بيستعملش. فبداوا يلجأوا للاورجانيك اسيدز مع الهيت تريتمنت في مصانع الاعلاف علشان توصل للهيلث هازارد. فانا بشكر كل الناس اللي مفكره في الموضوع ده وان هي بدات سابقه وبطلت تعمل فورمال دايت. ممكن يكون هو استبق ويدور على المصلحه العامه، لان هو ما شافش الدراسات دي، والدراسات دي احنا بنقدمها النهارده. كمان الناشونال كانسر انستيتيوت اعتبر ان استعمال الفورمال دايت جزء من البريدسبوزنج فاكتور او الحاجات اللي بتسبب للكانسر. علشان كده وكمان الفورمال دايت نفسه بيأثر على المواد الغذائيه اللي داخله الطيور منها اللايسين، بيقلل البايو افيلابيلتي بتاعته. فلو احنا شفنا هنا هنلاقي اللايسين في النون فورمال دايت امتصاصه او البايو افيلابيلتي بتاعته 1.25، في الفورمال دايت 1.14، وده في اللاير سيجمنت. لو احنا دخلنا على البرويلر سيجمنت هنلاقي بيأثر على معدل الافريج ديلي جين بيقلله. فده معناه ان هو بيأثر على المربي النهائي كمان في الفيدنج بتاعه. فهو محتاج يرجع يفكر في النقطه ديت. مش معنى ان انا اعمل كنترول على السالمونيلا اثر على الديلي فيد جين وفي نفس الوقت اثر على الهيلث بتاع البيرد والهيلث بتاع الهيومن. برضو دي في اللاير اثرت على اللاينج ريت بالسلب والايجاب. بالسلب قللت اللينج ريت، ودي طبعا البروفيت جاي من اللينج ريت، لان كل ما الفراخ اي فراخ بيضاء مهمتها ان هي تبيض، فكل ما تبيض اكتر كل ما تجيب فلوس اكتر. الافرج ديلي جين والافكت كمان على السويمز دي ما تهمناش. الافكت على الرومننت شافوها في اللام، لو ان هي بتاثر على اللام في الامتصاص، ودي حاجه تهمنا جدا احنا هنا موجودين، لان هي الفاينل بادي ويت بدا يتاثر باستعمال فورمالدهايد. فاحنا فقط مش ان هو مضر، لا كمان اقتصاديا العائد بتاعه اقل. فلذلك هو اتكلم على هذه النقاط لان هي المنتشره، واحنا بنصحح الكونسيبت بتاع اللي موجود، مش عشان الفورمالدهايد باند بس، لا عشان احنا يهمنا الانيمال هيلث سيكتور والهيومن هيلث سيكتور يبقوا الاثنين ماتشنج مع بعض. الجدوى الاقتصاديه منهم اعلى من ان احنا نوفر فلوس من المنتجات. الفورمالدهايد الترناتيف بنستعمل اورجانيك اسيدز، مش هنخش في الجزء الكوميرشال ده كتير، ممكن نتكلم فيه بعدين. ولكن احنا عندنا بيليتد فيد وماش فيد. البيليتد فيد ده بيبقى هيت تريتد، واحنا عايزين نحافظ عليه بعد النقل، فلذلك بنستعمل اورجانيك اسيدز، وبنعمل له حاجه اسمها شيلف اكستنشن وفيد هيجين، فبيبقى سهل الكنترول عليه. الماش فيد ده ما فيهوش هيت تريتد، فبيبقى محتاج فوكس اكثر علشان كنترول السالمونيلا فيه. زي ما انا قلت ان هي واحده من الحلقات اللي موجوده في السالمونيلا كنترول بروجرام. يعني العلف هايلايت عليه لان العلف اكبر تكلفه في دوره الانتاج بتاعه الحيوان سواء كان او رومننت، فلذلك دايما بتبقى التركيز عليه، ولكنه جزء من السايكل بتاعه السالمونيلا اللي هي لازم تتعامل كسايكل مقفوله: علف، فارم، هاتشري، مانجمنت، هيجين، ووتر، من كل الاتجاهات اللي مصنع عارف جزء منها. دي فورمالدهايد الترناتيف، دي الترايل اللي اتعملت عليها بالفايلكس اللي هو عباره عن بليند اوف اورجانيك اسيدز، وطلعت النتائج بتاعتها في تشفيع السالمونيلا افضل من الكنترول، وتقريبا زي الفورمالدهايد بتكون افضل من الفورمالدهايد. فلذلك نو نيد ان احنا نستعمل فورمالدهايد اني مور. وكمان حفظت لنا الشيلف لايف بيتر 3 مرات عن اللي موجوده في الاذر برودكتس وعن الكنترول. فمعنى كده ان المربي يقدر كمان لو حصل عنده اي ديستربنس موجود في المزرعه وعاوز يكيب العلف جوه المزرعه، فممكن يحفظه كمان. الشيلف لايف بتاعته اوريدي دلوقتي اكستند 3 تايمز عن اللي هو كان بيحفظه قبل كده. ده الشكل بتاع الكنترول فورمالدهايد واثناء استعمال الشيلف لايف وشكل العلف بدون مولد. دي الشيلف لايف دايز فورمالدهايد. دي تجربه اتعملت على ان الفورمالدهايد ازاي اثر على الكولونيز بتاعه السالمونيلا، وتحولت من 19250 كولوني ل 1350 كولوني باستخدام الاورجانيك اسيدز. والاورجانيك اسيدز هنا اورجانيك اسيدز بيور بدون معامله حراريه، مع المعامله الحراريه هتبقى النتائج افضل والريكونتامينيشن كمان هيبقى اقل. دي معموله هنا الريكونتامينيشن، ودي اهم نقطه في مصانع الاعلاف، علشان مصانع الاعلاف معظمها بيبقى عنده هيت تريتمنت، فكده كده هيطلع سالمونيلا فري، بس النقل لازم نحط حاجه تمنع ريكونتامينيشن اثناء النقل عشان توصل المزرعه فري فروم سالمونيلا والعلف فري فروم سالمونيلا. فكان التريتمنت بالاورجانيك اسيدز الفسال فلو او الفايلكس فلو مهم جدا للتريتمنت عشان نمنع ريكونتامينيشن، بالاضافه الى القضاء على ما تبقى من السالمونيلا داخل مصانع العلف تصبح العلف خالي من السالمونيلا. دي كمان احنا بنقول للمربي النهائي هو هدفنا كلنا، لان احنا هدفنا نوصل له فيد هاي كواليتي، فيد يكون ليس فيه اي انتروبكتيرياسي او سالمونيلا، وبمعنى صح يكون هيلسي، علشان احنا كبشر مستهلكين بنستعمل هذا اللحم او هذا البروتين في النهايه. فدي تجربه حصلت لنا على بعض الدجاج، كان الكنترول الاف سي ار في 1.31. لما استعملنا كمان الاورجانيك اسيدز الاف سي ار اتحسن وقل بقى 1.30 و1.307. فمعنى كده كمان ان هو له جدوى اقتصاديه عند المربي، لانه هيدي له تحويل افضل فيدي له مكسب اكبر. ولكن احنا بننظر هنا للفائده الهيلثي فود للانيمال والهيومن، ومع ذلك بنتكلم في جدوى الاقتصاديه لان احنا كلنا بروجكت كوميرشال يهمنا نكسب، بس في نفس الوقت نحافظ على الكونسيومر هيلث. فاحنا كاتبين هنا بيتر فيد كونفرجن ريشيو ايفن ادنج 20 كيلو جرام اوف ووتر، يعني مهما حطيت ما عندكش مشكله. السمري احنا قلنا المحاضره كانت عباره عن جزئين: ازاي نخلي المويشر تبقى موجوده، اللي بتفقد من العلف تبقى موجوده فيه بدون ما تفقد، نتيجه الجرش ونتيجه المعاملات الحراريه الموجوده مصنع العلف، عشان مصنع العلف ما يخسرش، لان ده حقه ان هو ما يخسرش، لان هو طبعا بيشتري رو ماتيريال من بره لها بارامترز معينه، واثناء التصنيع بيفقد هذه البارامترز، وهذه البارامتر جزء من المغذيات الاساسيه للطائر والحيوان. فاحنا بنرجع كل حاجه لاصلها، وبنحافظ على الرو ماتيريال ديت، فبنعوض الفاقد من الجرش، وده بنعوضه باستخدام السمارت ديجيتال ابلكيشن سيستم. والسمارت ديجيتال ابلكيشن سيستم دي بتقيس كل حاجه جوه العلف اثناء الدوزنج، وبعدين تعمل دوزنج على اساس الرو ماتيريال اللي احنا شارينها بالفاتوره. لذلك المصنع العلف اللي بيفقده بيرجعه تاني، اللي هو يعتبر فائد للطائر او للحيوان في النهايه. بالاضافه لده بيبقى فيها السالمونيلا كنترول، اللي انا علشان اضيف سالمونيلا برودكت كيلو على العلف، لا انا اضيف 20 كيلو علف، اضمن توزيعهم في حبات العلف كامله، فكل طائر هيوصل له الاورجانيك اسيدز التي تسيطر على السالمونيلا في حبات العلف، ولا تسمح للسالمونيلا بالجروح في حبات العلف. وكمان هتحافظ على الشيلف لايف بتاع حبات العلف، وكمان هتسهلي نقل حبات العلف. وكمان لو المربي حصل عنده اي ديستربنس جوه المزرعه وعاوز يوفر العلف، او العلف يقعد عنده اسبوع، يقعد عنده 10 ايام، فما فيش مشكله من الشيلف لايف، يبقى كل الجهات مستفيده. مصنع العلف مستفيد، المربي مستفيد في التحويل، ومستفيد في الحفظ بتاع العلف، في نفس الوقت عمل سالمونيلا كنترول على العلف. فكده اكبر جزء بيواجهه في مشكله السالمونيلا والعلف، في حل مشكله العلف فيه. انا في ناس كتير جدا تقول لك احنا بنعالج العلف حراري، فالعلف حراري ما يبقاش فيه سالمونيلا. الكلام ده مظبوط 100%. العلف المعالج حراري ما يبقاش فيه سالمونيلا، ولكن اثناء النقل ممكن يجي سالمونيلا، اثناء الاختلاط بتاع العمال يجي سالمونيلا، فلازم العلف يبقى تريتد من السالمونيلا. ركزنا كمان على الفورمالدهايد بيزد في الاديتيف، لان الفورمالدهايد كارسينوجينيك وباند من اوروبا، وبدا يتوقف الشغل بيه علشان حفاظا على صحه الطيور والحيوانات وصحه الانسان. واحنا هدفنا الاول، احنا كشركه تراون نيوتريشن شركه بحثيه وبتصرف على الار ان دي حوالي 60 مليون دولار في السنه، والهدف ربحي اي نعم لان احنا كوميرشال، ولكن بما يتماشى مع الهيومن هيلث والانيمال هيلث، لان احنا السلوجان بتاعنا فيدنج ذا فيوتشر. انا كده خلصت، ولو في اي اسئله ممكن نترجمها للبرنس. يكون معنا الدكتور عبد الله والبرنس، لو في اي اسئله تبقى موجوده نترجمها ونجاوب عليها. شكرا لكم وجزاكم الله خيرا حسن الاستماع. عبد الله انت ممكن تترجم الاسئله للبرنس.
Assalamu alaikum. Thank you for attending and having all this very good questions. Actually, let me introduce myself first. I'm Dr. Abdullah Fathi. I'm Technical Sales Manager, Saudi Arabia for Travel Nutrition. I will go through the questions with Prince, and then we can have an answer from Prince about these questions. Prince, can you hear me?
Yeah, I can hear you loud and clear. Thanks, Abdullah.
Yeah. Thank you. We have the first question about we need an advice about the different products available in the market, and they all claim they have they will control salmonella. This is the first one about different products. Second one, how we can choose the best one through this variety, and meanwhile, how what's your insight about salmonella vaccination? So
Yeah.
Triple questions.
Yeah, indeed. So the first part of it, let's take it the part by part. The first part is regarding the advice on different products available in the market. I think that's a very good question, because I know many suppliers, including us, I think we have a number of products in the market, and sometimes it can be very confusing to choose one and which one to use. So I think there are a number of factors to consider before making a decision. First decision, as I was also indicating in one of the decision trees, is what kind of feed is being treated. Is it mash feed, or is it raw material, or is it the final feed? I think that's the number one question to ask, because the kind of products which are used for non-heat treated feed, what says heat treated feed, they can be very different. For example, why I'm saying that, the products which are used to treat heat treated feed, which is steam treated pelleted feed, there the major risk of salmonella is recontamination. Because of heat, majority of salmonella is already taken care, so we need to take care of recontamination. Then we need to focus on a product which can take care of that recontamination. That means it should have more or a good balance of buffered products in it, buffered acids in it. So that's the number one thing to consider what we are going to do. While on the other hand, if we have mash, there our major challenge is decontamination. Because it is not treated with steam, the chances is there that it already contains salmonella or other microbes, and we need to take care of them. Then we need to hygienize it or decontaminate it. Then we need to focus more on a product which has more level of free acids in it, thereby taking care of the decontamination. So that's number one, how we can differentiate. The other thing to look into it is what kind of products we can use. So not every feed mill is same. Some are more comfortable in using powdered products, while some are good at using liquid products. So I think that's the other difference to look into. My suggestion would be, if you can use liquid products, if you can handle liquid products, then please use liquids, because they are more effective. Both they cost less, while on the other hand, they are also more effective. So it's always, in my opinion, more wise and prudent to use liquid. So that's the other part of it. I think these are the things which come to my mind, but there can be other number of factors. Please contact us, and then we can also run, for example, a customized laboratory test that which product at what dosage is best suited for you, and we can also help you really tailoring a solution. So that's the first part of it. That how we can compare the products and which one to use, so that is taken care of. And you're also asking, I think that's also a very good question, that on salmonella vaccination. I think vaccination is a good strategy, but there are also a number of challenges in using the vaccination. Especially, I'm not sure, here in Europe, not many people use it for broilers, for example. It's a good strategy for breeders. And there are challenges. When I say challenges, it's also not known to act against all kinds of serotypes and serovars. So that's something to keep in mind also. So I would say to use this multiple hurdle technology, I think it's a good one. When, for example, in breeders to use, please use it along with the other things such as preservatives, biosecurity. So like I was saying in the presentation, there is no golden bullet. So we have to have different strategies in place to counter the salmonella threat. So yeah, that will be my call on it.
Thank you, Prince, for answering the questions. We have another question. What is the optimum moisture?
Yeah, that's also an excellent question. I think very simple question, but also very thoughtful. I think that what is the optimum moisture? The optimum moisture in my mind is, there are different markets. First of all, they think optimum moisture in a different way, but optimum moisture, I think, should be the one what we are formulating the feed for. What nutritionist is formulating the feed at a certain moisture, keeping a certain moisture in mind. I think that should be the optimum moisture. That should be our target moisture to keep in mind. So which is usually, in case of poultry, is around 12%. Of course, there are regional variations, 11%, 12% or so, but that's usually something to keep in mind.
Very good. We have another question. It's in Arabic, so I will do the translation. It's asking about if we can maintain or preserve the moisture from the first part, from the storage, not through the mixing.
Sorry, can you repeat, Abdullah?
If we can preserve the moisture through the storage, not through the mixing.
Okay, yeah. Yeah, I'm not sure how to do it during the storage. Of course, if this question is related to, for example, the kind of packaging we are using or how we are storing the things, I think they are equally important in terms of keeping the moisture intact. But I think our first objective should be to get the right moisture within the stored product. So when we produce at the right moisture, what we are intending to do, and then the next level is, of course, to protect that moisture by using right kind of products, like we say humectants and the surfactants, which can bind the moisture and keep it there, but also using the right kind of packaging, storing it in the right area so that the moisture is not going out.
I think, Prince, he's meaning that from the raw material level, before the mixing.
Yeah.
Not after the mixing.
Okay, so before mixing, how we can manage the moisture? Oh yeah, sorry if I didn't get that right. Okay. Yeah, we can do that. But then there are a number of challenges. Why we don't do that, in my opinion, is because then how we, for example, we treat corn or soya, and then it's very difficult to grind something which has been moisture treated. The cost of grinding and the difficulties and challenges in grinding will be much higher. And also the storing of anything which has been moisture treated, specifically small, for example, when the particle size is very small, after grinding, it's very difficult. It will stuck in the silos. So that's why I think the advice is always to do it at the level of mixer and not before that.
Yeah, I will do the translation for this. أحد المشاكل اللي احنا بنواجهها إن احنا ما نقدرش نخزن الرطوبة من البداية من الرو ماتيريال عشان الكوست بتاعت الجرش نفسه، وكمان هيحصل لنا مشاكل واحنا بنجرش هتبقى أكتر بكتير من اللي احنا ممكن نعمله عشان نحافظ على الرطوبة through the mixing أو خلال الخلط نفسه.
بعد اذنك يا عبد الله ممكن اضيف حاجه هنا. في اماكن بتعمل الاثنين يا جماعه، بتعالج الرو ماتيريال نفسها للرطوبه، وبيبقى معاها انتي مولد تحديدا علشان يمنع اي مولد جروس فيها واي توكسينز تطلع موجوده. فبيبقى كده عمل كذا حاجه في حاجه واحده بس. اولا حافظ على الرو ماتيريال بتاعته من التعفنات. ثانيا حافظ على الرطوبه بتاعته انها تفقد، لان هي الرطوبه جزء مهم جدا للطائر لانه يعتبر نيوترال فاليو موجوده. النقطه الثالثه اديها مده اطول من التخزين. وبعد كده حافظ على الرو ماتيريال بتاعته ما يظهرش فيها سموم جديده، لان السموم اليومين دول برضو حاجه مهمه، يعني مهمه جدا مع السالمونيلا نبدا نبص عليها. ففي ناس بتعامل الرو ماتيريال وبيعامل في المصنع كمان، يعني هو عامل تكلفه دبل على نفسه عشان يوصل لاعلى جوده من الانتاج. انا بشكرهم جدا، وبتمنى الناس كلها تبدا تفكر تعالج الرو ماتيريال وتعالج جوه المصانع.
We have another hint in Arabic, Prince, that it's clearly that we're not selling water, but the main purpose is maintaining the moisture inside the final product.
Yeah. So the main purpose is not to add water, but to maintain the water.
Yes, exactly.
Yeah.
Exactly.
Yeah, indeed. I think that should be the absolutely our objective. Our objective is not to increase the moisture and to sell moisture. Our objective should be whatever moisture we are, whatever our target moisture is when we are, making the recipe of the feed as far as nutrition is concerned, we should be concerned about reaching that level. So if we are formulating for 12%, we should reach 12%. But what happens more often than not is that we formulate at some level, there are a lot of variations. There is a process loss during feed milling. We always usually end up, especially in the Middle East and tropical countries, that there are a lot of this the temperatures are very high, humidity is less, then we end up losing moisture. So the idea is to recover that loss and to maintain whatever we have formulated the feed for. Indeed.
Thank you, Prince, for clearing that. We have another question. If the feed containing phycel, it is beneficial for reducing salmonella from birds if other sources in the feed is suspected?
That's an excellent question, but yeah, I think I have to disappoint you. Of course, there will be some effect, but it's very important that we take care of salmonella from other sources also, whether it is biosecurity or water. It's important that we take care of it with separate strategies. So I think phycel is important as far as feed is concerned, but the salmonella needs to be taken care from other angles by using different strategies.
Thank you, Prince. Is there any antagonism for phycel feed with probiotics?
Yes, on one there can be. It depends what kind of probiotics, etc., which we are talking about. Sometimes, for example, in silages also, so I'm just taking an example of silage, we don't see any effect on lactic acid, for example, lactic acid producing bacteria, not much, because when we reduce the bad bacteria, the good bacteria automatically go up. But also the other thing is feed metrics. The feed is very large metrics and the products which we use is less. So it's the probability of probiotics coming in direct contact with acids is also less. That's what we have seen in the field. But one-on-one, if we mix them, for example, then of course these acids will have an effect on probiotic and they will kill them. But within the feed metrics, yeah, I don't see a problem.
Very good. What is the most effective types of acids and percentage for controlling salmonella?
Yeah. What do you mean? The percentage of acids, or? Sorry,
what type of acid can we use for controlling the salmonella, and what is the percentage for that?
Okay, yeah. Usually, the most effective acid against salmonella is formic acid and its salts. So that's the most effective ones. But to make it further more effective, we can have a blend with an emulsifier or use different kinds of acids. I didn't have that kind of slide today, but different acids have different level against different kinds of species, not only salmonella, but different enterobacteriaceae species also. So in general, as a rule of thumb, it's formic acid, but I think that will be a little bit overgeneralization also. So I'll really suggest you to look it as a blend. There are different organic acids which can have different effect against different species up to a different level.
Very good. There is another question about if the good storage practices in the farm during the use, it's very beneficial. It can help us, the good storage in the farm before the using.
Certainly, I think all our the managemental practices definitely have an impact. I think products, etc., all come later on. It's first is our managemental practices, whether it is at feed or farm. So that's certainly very important. And I think even if we are using the product, we should be maintaining those kind of good storage conditions, packaging, etc. Yeah.
Very good. We have another question. Does the product can control salmonella infection that come from field?
That come from field. So yeah, if this means, for example, biosecurity challenges, when the feed is there and somewhere else is coming from. So since this product has a little bit of residual effect, as we see, that means it keep on acting even when the feed is being transported outside of feed mill or even when it has reached the animals. So it has that residual effect. But does that mean that we need not to take care of our biosecurity at all? So no, we of course need to have good managemental, good storage, biosecurity in place. But even after that, if something breaches that and can reach the field, so we have an additional hurdle for the bacteria to reach the animal and an additional effect in terms of product. So I hope that answers your question.
Yes, sure. Can I add one point here?
Yeah, please.
Point. Feed which is treated by this product, yes, it's protected, but it is one of the cycle of the one pillar of the cycle of salmonella. I will translate it again in Arabic. السالمونيلا كنترول بروجرام وليس برودكت. بروجرام للعلف، للميه اللي بيشربها الدجاج، للفارم نفسها، الهوايات اللي موجوده في الفارم، للعمال اللي موجودين، الميه اللي بتنزل لهم للشرب، للفرشه اللي موجوده. كل الحاجات دي لازم يتعمل عليها اوديت، وده اسمه سالمونيلا كنترول بروجرام. جزء من البروجرام سالمونيلا كنترول للفيد. الفيد اللي متعالج بالفسائل از اكزامبل او الاورجانيك اسيدز بيحصل له ريكونتامينيشن، المفروض لا، علشان دي بترجع للكواليتي بتاعت البرودكت. فالمفروض ان الفيد اللي متعالج طالع من المصنع فري فروم سالمونيلا ومش هيحصل له ري انفكشن، لان الريكونتامينيشن اتكلمنا عليها نقطه مهمه جدا، وديت من الاساسيات اللي يستعمل عشانها المنتجات، الريكونتامينيشن. انما الانفكشن جوه الفيلد من الفارم نفسها او سورسز اخرى للدواجن خارج الفيد ممكن تبقى موجوده.
Thank you, Dr. Mohammed. Prince, we have the last question here. It's about describing the surfactants effect on animal if we use it for reducing surface tension.
Yeah, I just read in between the lines for this question that I know there are emulsifiers in the market which also claim an effect inside the animal. So maybe this is related to that. But usually the surfactants are of many types and they are usually classified on a scale, HLB scale, as they say, hydrophilic lipophilic balance. So the kind of emulsifier / surfactants which I'm talking about has more effect inside the inside the, let's say, feed, but not inside the animals. So I think the surfactant effect which I'm talking about, that it doesn't have a direct effect inside the animals. It's really in the feed.
We really we are sorry, we are run out of time and we are I think 20 minutes over. So thanks for you all, thanks for your events, thanks for your attendees for attending this webinar. It will be inshallah first one we can organize more about salmonella control program in all aspects and all field. شكرا لكم جميعا على الحضور، وبنتمنى ربنا ان نكون فدناكم وعرفنا نوصل المعلومه. واذا اي حد عنده كونسيرن او عنده سؤال ممكن يبعته لنا وان شاء الله نجاوب عليه في اقرب فرصه ممكنه وباسهل طريقه وبشكل واضح. وان شاء الله نتمنى الوزاره تسمح لنا تاني ان احنا نعمل ميتنج تاني نتكلم على السالمونيلا كنترول بمراحله كلها. وبنشكرهم جميعا وبندي الكلمه للدكتور فهد لو هو حابب يضيف اي حاجه ان شاء الله ويختم شكرا دكتور فهد.
باذن الله. شكرا. نيابه عن مدير اداره الصحه والرقابه البيطريه الدكتور علي الدويرج، اشكر القائمين على هذه الفعاليه ترو نيوتريشن هيفيد وشركه المملكه العربيه السعوديه وشركه الاعمار العالميه للكيماويات والبيطره. طبعا نتمنى الاستمرار مثل الشراكه بين القطاع الحكومي والقطاع الخاص لمثل هذه الفعاليات مما يعود النفع على المستثمرين والمهتمين بشكل عام. كما يسعني نشكر بالخصوص مستر برنس والاستاذ محمد والدكتور عبد الله والدكتور سامي والحضور. السلام عليكم ورحمه الله وبركاته.
Thank you so much.
Thank you. وعليكم السلام.
عليكم السلام دكتور فهد وشكرا لكم. والمحاضره مسجله وموجوده على اليوتيوب للي عاوز يرجع لها ويتابعها ويسال.